What was this?
No, it's not a class. Just I was saying.
Okay. And this current trial involve patients, these trials, the previous trials involve patients with moderate to severe major depressive disorders. And the aim is to perform a phase 2 double-blind randomized control trial involving patients with long-standing moderate to severe disorder.
Sorry, we can't hear you. Did you mute by any chance? Oh, I don't know what happened. Okay, I've unmuted you. Could you start? Maybe like the last 10 seconds. Sorry, I don't know what happened. You were muted. Go ahead.
Okay, ma'am. Okay, the background of the study. Psilocybin may have an antidepressant property, but it has not been compared with a standard antidepressant like selective serotonin reuptake inhibitor, which a prototype type is escitalopram. Escitalopram, as well as other selective serotonin reuptake inhibitor, takes about 2 weeks to act. This is because of their mechanism of action, which has a lot to do with activation of serotonin transporter in the brain. This psilocybin, which is a psychedelic compound, is seen in mushrooms and can occur through serotonin 5-hydroxytryptamine type 2A, which has an antidepressant property. Even though an open label trial and 4 randomized controlled clinical trials of psilocybin for depression and anxiety have been conducted, there is reported reduction in depressive symptoms after administration of 1 or 2 doses of psilocybin, and also in inpatients with treatment-resistant depression, results of which informed the current trial. The specific aim is to perform a phase 2 double-blind randomized control trial involving patients with long-standing moderate to severe depressive disorder, comparing psilocybin and escitalopram over a 6-week period. Then the location and setting. The location is in National Institute of Health Research, Imperial Clinical Research Facility, from January 2019 through March 2020. Then the referral methods are usually were self-referral. Information about the trial were made available online at websites like Center for Psychedelic Research websites, clinicaltrials.gov websites, mental health research recruitment platforms. Volunteers initiated contact by emailing the recruitment coordinator. Most recruited referred themselves. Then the subject and sampling method. Men and women between the ages of 18 and 80 years were recruited formally through trial networks and informally through social media and other sources, which directed patients to the recruited websites. And this was also the inclusion criteria. But patients with immediate family or personal history of psychosis and pre-existing psychiatric conditions like borderline personality disorders were excluded. Other ones excluded were medically significant health conditions that makes someone unsuitable to participate in the trial. This was as assessed by the clinician. Then history of serious suicide attempts, positive pregnancy tests were all exclusion criteria. There were also people that were excluded were also people that are have contraindications to taking SSRI or undergoing MRI. Then previous history of escitalopram, though previous history of psilocybin were included in the research. Then the approval of the study and ethical issues. The approval was the drug license from the UK. The Home Office was obtained by the investigation and the trial approved by the Brent Research Ethics Committee UK, Medicine and Healthcare Products Regulatory Agency, the Health Research Authority, the the Imperial College London, Joint Research, Compliance and General Data Protection Regulation Offices, and the Risk Assessment and Trial Management Review Board, National Institute for Health Research, and Imperial Clinical College, Imperial Clinical Research Facility, CRF. Then the materials and methods. Candidates were sent a patient information sheet and invited for a telephone screening. The assessment was with a 17-item Hamilton Depression Scale, which was performed via video call, and a score of at least 17, indicating moderate to severe major depression, was required for trial enrollment on a scale ranging from 0 to 52, with higher scales signifying greater depression. Confirmation of diagnosis of depression and medical history were obtained from candidate's general physician. The eligible patients underwent face-to-face physical and mental health assessment with a trial psychiatrist. The patient discontinued any use of psychiatric medication before starting the trial, with full discontinuation occurring at least 2 weeks for the medication and 3 weeks for psychotherapy. After the telephone screening, each candidate was assigned to 2 supervising mental health specialists, which their cadre ranked from clinical psychologists, psychotherapists, or psychiatrists, or their trainees. And their duty was to build a therapeutic alliance with the patient before, during, and after each day dosing. The mental health professionals were present for all the trial visits. Baseline assessments were completed between 7 to 10 days before trial visits, and all the candidates had an informed consent after screening and agreed to 6 visits over a 6-week trial period. Adverse effects were recorded at every visit, and telephone call from dosing day 1 through week 6 were also recorded. The randomization was by staff members who were not part of the team. This ensured the double blind. Procedures for the investigation of psychotherapeutic agents and size, color matched placebo capsules were consistent between the trial groups. There were about 6 visits. Visit 1 was for baseline, where the functional MRI was done. Then a completed cognitive and affective processing tasks were also assessed for the 2 groups. Initially, it was 3 groups. 1 group for the psilocybin, then the other group for the escitalopram group, and then a placebo group that was later ruled out because of costs. Then the visit 2 is a day after visit 1, and patients in the psilocybin group, they received 25 milligrams of psilocybin, and those in the escitalopram received 1 milligram of psilocybin, which is with the dose which was found to be negligible. All the patients were pre-informed that they would receive psilocybin, because during the time of referral, during the time of indication of interest, they found out that more participants had interest in psilocybin. So most of them received, the first group, the psilocybin group received 25 milligrams, while the escitalopram group received 1 milligram. The medication and placebos were all packaged with non-disclosing labels. All the investigation and medication administering staff were unaware of the trial group assessments. The dosing days for each patient or participant were supervised by the 2 mental health professionals already selected, who had been assigned to the patients. They were caring for the physical and the psychological well-being of the patient and responding to signs of patient discomfort during and immediately after each dosing. A trial psychiatrist assessed eligibility for discharge when the functional status of the patient had returned to baseline, and also assessed the patient before the patient left for the Imperial Clinical Research Facility after visit 2. After visit 2, they received some capsules, which they were instructed to take 1 capsule each morning until their next scheduled day of psilocybin dosing. The capsule contained either placebo for the group that received 25 milligrams of psilocybin or 10 milligrams of escitalopram for the escitalopram group. Then on visit 3, which is a day after the first visit, it included psychological debriefing, which is like a therapy. They assessed the therapy. It was an additional therapy was conducted for the patients either on telephone or video call, which occurred a week after the visit, the third visit. Then the fourth visit is 3 weeks after the first dosing. The patient received second dose of psilocybin or the placebo during the day 2. Then on visit 5, which is the next day after the visit 4, a psychological integration session involving open attentive listening of patient's problem, which is like a psychotherapeutic measure for the patient. After the dosing, the patient were asked to take 2 capsules from the drug bottle each morning, which was either the placebo for the psilocybin group or the 20 milligram of escitalopram for the escitalopram group after the next visit. Then the visit 6, which is the last visit, is 3 weeks after visit 5. Assessments of the primary outcomes, similar to visit 1, were done, and performance of functional MRI 6 weeks after the first visit was also done. Then cognitive and affective processing tasks, which was also part of the baseline assessment that was done for the patient, was repeated. And then final clinician rated assessment and psychological debriefing was also done for the patient. After these assessments, the patient and the trial staff were informed of the trial group assignment, and the trial psychiatrist discussed future treatment options. Note that in the escitalopram group, discontinuation of the trial group was managed by the patient and their general physician. After 6 weeks, it was followed by 6 months. They were followed for 6 months by the investigators, but that didn't fully collect. They didn't fully collect the data up to 6 months. Hence, it was not analyzed. Initially, there was a placebo group, which was supposed, like mentioned, there were 3 groups initially, but this was not carried to later because of the complexity of handling 3 groups at a time. Data obtained from the imaging group in the trial was used to predict responses to the trial drug have not yet been analyzed. Then the outcome and summary of the findings. There are 2 outcomes, the primary and the secondary outcome. The primary outcome, which is change from the baseline in the score of 16-item quick inventory depressive symptomatology, a self-report questionnaire that has 6 items, with a score of 0 to 27. Higher scores indicating greater depression was done at 6 weeks. This is for the primary outcome. And when it was assessed, it was found that there was no difference in the 2 groups. But for the secondary outcome, which was a response after 6 weeks, according to the quick inventory depression symptomatology,
We seem to have lost her there. Let's see. Dr. Ijoma, are you still there? Can you hear us? We can't hear you. She's still connected. Oh, she's muted. You can unmute. Dr. Ichoma, we can't hear you. Okay. We can't hear you. Okay, all right. She's back again.
Yes.
Yeah, go ahead, please.
Okay, the summary of the findings. There are two possible, there were two outcomes recorded, the primary and the secondary outcome. And the primary outcome was from the change from the baseline to a score, change from the baseline using a score, a 16-item questionnaire, which is a quick inventory of depressive symptomatology self-reports, scoring from 0 to 27 at 6 weeks. It was found that for the two groups, there were no significant difference. But for the secondary outcome, which involved more questionnaires, like the Hamilton depressive, like the quick inventory depressive symptomatology, the Hamilton depressive rating scale, and the Montgomery aspect depression rating scale, as well as the flourishing scale, among others. It was found this assessment was done after a response that was done after 6 weeks. It was found that there were a better outcome were seen in psilocybin group when compared to escitalopram group. Then the summary of the results. For this trial, 1,000 patients were screened on telephone. 103 attended informal screening visits, and 891 did not meet the inclusion criteria. While 19 had psychiatric conditions, 50 declined to participate. Thus, 59 patients were enrolled and underwent randomization. 30 was given ascribed to the psilocybin group, while 29 to the escitalopram group. 39% had completely discontinued a psychiatric medication prior to this indication of interest, while 7% discontinued psychotherapy. 5 did not complete the protocol requirements, and 4 stopped taking their escitalopram capsule because of the side effects. There was 1 missed dosing for the day 2 and subsequent visits due to COVID-19. And 1 patient in the escitalopram group guessed the capsule and guessed the capsule contained escitalopram and reduced the dosing by half. Hence, taking 10 milligrams of escitalopram, which was not against the trial rule. In the psilocybin group, 3 of the 30 did not complete all the dosing procedure. 2 mixed the dosing for day 2 and subsequent visits because of COVID-19, and 1 stopped taking the placebo. The mean age for this trial was 41, 20 of which was women and mostly white. Depression, then the depressive patients were, the mean age was about 22 years among the patients in the psilocybin group, and then 15 years for the escitalopram group. The quick inventory for depressive symptomatology showed that there were the baseline during the quick inventory depressive symptomatology self-reports for the psilocybin group was 14.5 score, while 16.4 was for escitalopram, respectively. And this will be seen more in the effects of the results as well as the limitation of the study. There were more alcohol use among the patients in the escitalopram group when compared to the psilocybin group. Other characteristics were found to be similar in the two groups. From baseline score at 6 weeks using the quick inventory for depressive symptomatology self-reports, there were no significant differences in the trial group at week 6. But like we noted, the difference was favored to the group that took the psilocybin compared to the escitalopram. Then the percentage of patients that reported adverse effects were similar in the two groups, and the common side effects reported was headache for the two groups, which was found to be more in the psilocybin group. Then there's also a greater emotional improvement noted in the psilocybin group, as they were able to feel more emotions, cry and feel compassion, intense emotional pleasure, and less drowsy when compared to the other group. No case of visual perceptual changes and no psychotic symptoms or dependency were seen in both groups at 6 weeks. Then the outcome for both groups, the score on depression scale at 6 weeks were lower than the baseline score, but the absence of the placebo scale, the placebo group, did not give room to limit the effects for the two groups alone. Anxiety, dry mouth, sexual dysfunction, as well as reduced emotional responsiveness were higher in the escitalopram group when compared to the psilocybin group. No patient in the psilocybin group requested to quit, though the second psilocybin dose, while 4 patients in the escitalopram group stopped taking their medication and 1 half the medication. The 3 patients could not attend due to COVID-19. Then the critique. The strength of the study is that it's a randomized control trial, which is best for prospective study, as this is a prospective study, and the double blind also placed it high in the scientific pyramid of research. But the limitations noted by both the researcher and also the one I noted was that there was a brief duration of escitalopram treatment, as SSRIs takes about has a delayed therapeutic action on depression. Then effectiveness of blinding within each group was not assessed, as guessing of the trial group assignment could have given a biased expectation in favor of the other group, which is psilocybin. Then the referral method was also self-referral as against external referral, which was also in favor of psilocybin, as most of them indicated interest for this. Patients are mostly white and didn't give room to study it in Blacks and other ethnic groups, as well as socioeconomic backgrounds. The average symptom severity score at baseline were in the range of moderate depression, and this cannot be extrapolated to severe or treatment-resistant depression. 6 weeks is somewhat a short period to establish full comparative efficacy of a standard antidepressant. The period longer than 8 weeks should have been more ideal, which could have given a superior efficacy of escitalopram over psilocybin if this was allowed. The escitalopram group had more depression score at baseline, although it is not known whether this was significant. But if it was, it could have contributed to the outcome scores that we got finally. And this also should have been taken into consideration when analyzing. Any new knowledge. Psilocybin is typically not considered, there's a new knowledge because it's not really considered antidepressant in literatures. Before now, studies did not establish it as significant antidepressant property, and then comparing it over a standard antidepressant like selective serotonin reuptake inhibitor, which has a prototype of escitalopram, and then favoring it in giving it a favorable outcome, have not been studied before. Therefore, the findings of similar outcome scores with escitalopram on the primary depression measure in this study, and even a greater percentage reduction in depression scores in the secondary measure, appear unexpected for an agent previously adjudged to be adjunctive utility in the management of depression. Okay, for the possibility of replication in this environment, yes. But the investigators may need to follow up the subjects to detect and address any abuse tendencies. Thank you very much.
Thank you so much, Dr. Ijoma Charles, for that. Do you have any questions about maybe research design, choice of anything about research design or the technicalities of the paper for Professor Soyinka, or would you want us to go to the stats if he doesn't have any comments? Dr. Ijoma?
Okay, ma, I actually didn't prepare for any question for the.
Okay, all right. So you're very happy with the paper apart from your comments?
Apart from my comments, it's okay. It's a good trial.
All right. Thank you. So before we go to Q&A, I don't know if Professor Shoyinka has anything to say. I'm so very proud of him, my classmates. We did house job together too.
In urology.
Yeah.
I remember that vividly. Thank you, Dr. Kaltungo, Professor Kaltungo, for inviting me to be a part of this session, and it's such a pleasure to be here and with Professor Bakari as well, another one of our classmates, an esteemed colleague. Thank you, Dr. Ejoma, for your presentation. I think the one thing I want to add to the discussion for this at this point is to give a little bit of additional context, and there other people are welcome to weigh in. But the context for this study, I think, is increasing interest in what you might call non-traditional treatments for mental health conditions. In the behavioral health field, we have a lot of agents now, and increasingly we have more and more different kinds of biological agents. SSRIs are just one class of antidepressants, but we also now, of course, have things like TMS and, of course, ECT that's been around for a long time. This study, I think, is a good exploration of treatments or agents that had not been considered as an option for treatment in the past. And I think we're going to continue to see more and more of this kind of interest. So I'll just stop there, and given that I was actually quite interested to look at the findings and it seemed like, even though it's not conclusive, there seems to be a signal that psilocybin might be an option for treatment in the future. Of course, we're all aware of the increasing interest in marijuana for various physical health conditions, some of which again have not been substantiated yet. So I'll stop there and invite comments, of course, from Dr. Bakari and others.
Yes, thank you very much. So Dr. Bakari, if you'd like to weigh in before we take the data. Thank you.
Thank you, Dr. Tungo, for inviting me, and thank you, Professor Shoyinka, for this opportunity. Like you mentioned, Professor Shoyinka, psilocybin is a naturally occurring substance, and if this is proven to be a good means of treatment in the future, it will actually be a good breakthrough and more affordable for patients in terms of costs and all that. Since this is a preliminary study, more studies need to be done, and we need to look at other ethnic groups, just like the presenter criticized, that we should look at Hispanics, we should look at the efficacy in the Blacks community too, and see how this works. So it's an ongoing thing, and we hope it will be a breakthrough for future of science. Thank you very much.
Thank you, thank you. So I think we should just go straight, except if there's a specific question for the reviewer or those who have just spoken. I think we can go to, if there is, just put up your hands, else we'll just go straight to biostatistics. All right, thank you. So Mr. Felix, please do your thing. Thank you.
Yeah, hi everyone. Good evening.
Good evening.
So I would share my screen, and so the paper review, it's already done. Okay, so sorry, just a second. Okay, so the paper review, it's already done, and it's a trial. I think this is from the scale of measurement. This is almost like the highest, form of credibility when it comes to the research process. I think after this, we now have the systematic review. After the systematic review, we now have the umbrella review. So doing a trial in this sort of study, it's really good. So the main primary purpose is to actually test 2 antidepressants, So they had 2 drugs and they want to see which one will improve, the patient's condition, in terms of reducing the depressive symptoms or the depressive scale. Now, if we go to the tables, like for the table 1, which is the demographic and clinical characteristics, they looked at certain demographic characteristics.
I think you muted yourself. Mr. Felix?
All right, yeah, sorry
Okay,
about
all right.
that.
Yeah, go ahead,
Yeah,
please.
so I have demographic characteristics, the age. So the age was measured in years because it's a continuous variable. You can see here, they actually looked at the mean age between the psilocybin group and the escitalopram group. So we could observe that there is a higher mean age for this group compared to this group, but the difference may not be statistically significant really based on the values. But however, I think in this particular table, the interest is not really to know if there is a difference in this social demographic characteristics or in this aspect. Yeah, so they are not really focusing on whether there's a difference, but we can actually look at the figures, how they differ slightly, because this is really, really important, especially when you're using 2 groups, to be sure that there are no much variations between these 2 groups, so that at the end of the day, we could be able to say that the variations we are experiencing in the main outcome of the study, which is the ability of this drug to reduce depression, is actually or truly caused by the drugs and not by the demographic, or some other parameters, So it is good to actually have these parameters, side by side. So I think this is what has happened here. So for the continuous, they use the mean, and plus or minus, we have the standard deviation. Then here we have the range, the minimum age and the maximum age of the respondent. So for the gender, we can see that in this case, they use the numbers and the percentages, so where you have the frequency or the counts and the percentages, they are categorical variables. But where you have numbers, raw numeric numbers, there they would use mean and they will use standard deviation. I just wanted to say that using mean and standard deviation is not like it's a standard, like this is what is supposed to be done all the time. Certain times you can use median and interquantile range, but certain things are responsible for that decision. Now, if you are doing a study where you are collecting data that you didn't follow any form of systematic process in selecting your sample, you did more like a non-probability sampling. You just, like a convenient sampling, you just picked your participants at your convenience, or whichever way without giving everyone in that study group an equal chance of being selected. So in that case, there are possibilities that that data could be skewed, although we've been given an opportunity to test the normality of that data. So the reason why we test the normality of the data, especially using standard procedures like the Shapiro-Wilk normality test, is so that we can confirm that that data is not skewed. Meaning you didn't favor one particular group over another, you randomly picked your participants. So in a case where that data is skewed, then we will probably not be looking at mean and standard deviation. We would be looking at the non-parametric aspect, which is the median and the interquantile range. But for this kind of study, where you're doing a randomized control study, a trial, you are very sure that for you to be able to achieve this high level kind of study or this high powered kind of study, then you would follow all scientific procedure to ensure the credibility of the study and the accuracy of the result. So the sampling method will have to be part of the process. So in that case, there are little doubts that this data would be normally distributed. So the mean and the standard deviation would be the appropriate in this case. So I needed to mention that, because I don't want us to feel that anytime you have a continuous data, then it has to be a mean and a standard deviation. Most times it doesn't really have to be. Sometimes it can be a median and an interquantile range, especially for continuous data that are skewed. That's why sometimes when you send your paper for publication, sometimes the editor will ask for the result of the normality of the data, because they want to gauge why you're using the sort of summary statistics you are using. Okay, so that is it for this table. So they compare demographic and clinical parameters. For those that are numbers, they use the mean, the standard deviation, and the range. And for those that are categorical, they use the numbers, the counts, and the percentages in brackets. So these symbols here that have already been described on the table. So if we go further down, you would, hello? Is someone saying something? Okay.
Please go ahead. I'll just mute the person.
Oh,
thank you.
Okay, so if we go further, before we come to this chart, let's look at this table, which is the table 2. So this is where the cocoa of the work really starts, because the whole essence is to check the efficacy of the drug, its ability to cause a reduction in depression. So if we look at this, they have the first drug here, they have the second drug here. So they looked at the change in this parameter, and you can see the QIDS, there's -8 here, and there's -2 here, -6 here. All right, we still have the standard deviation. So we can see, for sure that we have a stronger reduction, reduction here, compared to here. And that difference is 2, which is simple arithmetic. 8 minus 6 is 2, because both of them are reductions. So we cancel the minus signs. So this was 6 weeks here. All right. So this is the primary outcome. Primary outcome meaning this is the cocoa of the study, the main thing that they want to get out of the study, which is checking for the reduction in depression. So it's very obvious that this causes better reduction than this, at least -2. So if we look at this symbol here, so that symbol gives us a P. I don't know if you're seeing what I'm saying. There's a symbol here which gives us a clue, because fine is, we know there is a difference. 2.0 difference. However, is there evidence that this difference is statistically significant? So that is why we have to check for the test of significance. And there's a symbol represented here. And if you go down, that test of significance for that primary outcome is P equal to 0.17. And you agree with me that 0.17 is greater than 0.05, which is the cutoff of evidence that a comparison of two parameters is truly different. So because that P is greater than 0.05, it simply means even if 8.0 has a 2-point reduction from 6.0, that difference is small. It's not strong enough for you to truly say that the psilocybin is better as an antidepressant, than the escitalopram, So this is where using evidence is it's thrilling, because if we don't use evidence like this, people will begin to make all kinds of insinuations based on differences they have seen, because the fact that your 10% is greater than someone's 6%, which is a difference of 4. If you look at the percentages, yes, you can actually say, oh, 10 is truly higher than 6. But that difference in 4 may not truly be significantly different, meaning it may not create an impact that the other one may not likely have. You see, so the moment we have checked, because the essence is to see how much reduction it will bring, we have seen that 2.0, but the evidence is showing that is not enough. So in other words, even if we have 2.0 reduction, and we've seen the p-value, we would not be able to tell that drug P is better than drug E, because the p-value is not statistically significant. A lot of times I know that because of this, I call it p-hacking. Sometimes I call it publish or perish. People just assume, look at this high-powered study. Some people wondering why I'm calling this a high-powered study. If you read this study, you will see that a lot of work was really put in this study. And the authors have invested so much to actually make these results available. And after, hello? And after investing all this, your primary outcome is telling us that there's no difference in these two drugs. And some authors will wonder, there's no difference. Why go through all this? Maybe we need to do something to this data. We need to tweak the data a little bit to show at least a significant difference, so that we will find a journal to publish it. Because people just feel, oh, if there's no significant difference, we may not easily find a journal that will publish our work. No, that's not true. So you find out that people commit what they call type 1 error. type 1 error is you have a null hypothesis, and your null hypothesis states, like this study with the primary outcome, the null hypothesis would be there is no significant difference in the reduction of depression between drug P and drug E. That would be our null hypothesis. We have done the research and we have seen that from the P value, there's no significant difference. As a researcher, what I'm supposed to do is to accept my null hypothesis that says there's no difference between P and E and get the paper published. But because I am worried that, oh, this thing is not significant, will they really publish it? I now begin to tweak the data a little bit. And by tweaking the data, I now reanalyze it and it's now significant. So what I have just done, I've committed a type 1 error, which says that you fail to what? To accept your null hypothesis, which is true. So the null hypothesis is true. There's no significant difference. Just accept it. But instead, no, I don't want to accept it. I want a significant difference. You took the data and you now have a significant difference, but you've committed a type 1 error because you fail to accept the null hypothesis that says there's no difference. So I know why I'm saying this, especially for early career researchers, because there's always this hype. There has to be a significant difference. There has to be a significant difference. It doesn't have to be. Whatever your outcome is, publish it that way. You would find journals that would be happy to publish your work. And I know sometimes as an early career researcher, you send your work to your supervisor and they're like, is this still not significant? I thought it would be significant. And you get very jittery. Oh, let me see what I can do. You're committing a type 1 error. Okay, so from this now, either drugs can be recommended because even if there's a difference, it's not really, so as a physician, you can recommend both based on the result of the study. So apart from the primary outcome, they also have secondary outcomes that you can see here, where they also checked for differences in different aspects, of the parameters they have measured, 6 weeks. So you can see, so all this particular one up here, they are numbers, counts and percentages. You can see the differences. Then for the continuous values, they are measured in means and standard deviation. So that is what has truly happened in the secondary parameters. However, I just wanted to say something, especially for early career researchers. We are very much aware that when you are checking for differences in means, especially differences in 2 means, like you have here, the 8.0 and the 6.0, the test of significance to use is actually the student t-test. Now, because the P is a different population from the E, they are independent population. They are not together. So we are going to be using the independent student t-test. All right. So it is actually a proper practice that when you compare 2 means, you don't only give us the p-value, because the p-value is not the test of significance. The p-value only gives us a clue on whether the t-test you have compared is statistically significant or not. So the p-value is the evidence for whether you would reject or accept your null hypothesis based on the t-test value you have gotten. So for early career researchers, it is proper practice that you put the test of significance, then you put the p-value. Okay, so that is really like if, like in a case where you are comparing percentages, differences in proportions, we would like to see the chi-square value and also see the p-value, but sometimes you may have, students just put only the p-value without giving us the test of, because by looking
Joanna.
at by looking at the test of significance,
Joanne,
we can tell
get.
what you have compared, whether you have compared means, whether you have compared percentages, proportions, whether you have compared medians, you know. That's why having that test of significance is actually a good practice, because once you just see the p-value, you may not be able to tell from the p-value what comparisons have been made, because the p-value is not the test of significance, but only an evidence on how we would interpret our result based on the test of significance. So that is what has happened here. So the table 2 is where the main result for the primary outcome is. Now, if we go to table 3 here, it's looking at the adverse events that have happened, because when you are doing a study where you have drugs in place, there would definitely be adverse events. So it is good to also check those, you know, because especially for drugs, for pharmaceutical people, they don't only consider the efficacy of that drug, they also look at the side effect of that drug. That's why at certain times a drug can be prescribed based on the side effects to a particular, you know, patient. And in another patient that does not usually have those kind of side effects, you know, they make, you know, so the point I'm trying to make is understanding the side effect of any drug that you are testing in a clinical trial. It's a standard practice because it's not only the efficacy of that drug, because if you test only the efficacy, what if the drug has so much side effect that it will even kill the patient before the patient gets better? You know, so you know, testing both is really good, which is what I like about this study too. It's very detailed, you know, also giving us the advanced you know, events that have happened. So from what we can see here, any adverse event, you can see this is 26, this is 24, you know, in the 6-week trial period. So you see, the difference is not so much 26, 24. So it's just to tell you that both drugs are as good as they can be, you know. No one is having much, you know, adverse events, you know, compared to the other, you know. So this is what the authors have tried to do, you know, and it's quite an interesting study, at least, you know, for physicians looking at this study. You can be able to make a clinical decision right away, an evidence-based decision. So once a patient comes, I mean, you either give P or you give E, you are very sure, you know, that both of them will be achieving almost similar effects. So I really appreciate the authors for actually taking the time to throw into the academic public this sort of research. So this is primarily in charts of what I have said so far. So you can see the red line is for the P, the E line is, the blue line is for the E. So if you can see the change, you can see that there is more drop, you know, for the depression. You see the P compared to the E, which is slightly upper. And that is the same thing the values are showing here. You can see the change is greater, the drop is greater for the P. So that's why I wanted to explain this first before we look at what is happening visually. I think I would stop here now for any question. Thank you very much. I hope this is helpful. Thank you.
Super, super, super helpful as always. Thank you so much for doing what you've doing this and making it sound so simple. So if there are any questions, you can just put up your hand or put them in the chat box, and then we will unmute you or read out your question if your camera is shy. Good. So I want us to wrap this up by 30 minutes after that. So I have about 16 minutes. So any questions, any comments? Sorry, Professor Shoyinka had to leave. He says he has another meeting. So if there are any questions for him, you might need to put it on the WhatsApp group and then I'll forward it to him. Any questions, any comments, everybody? Oh, okay, that's nice. Everybody understood. I don't see any hand up, so I'm assuming everybody is fine. Okay, so except if, okay, yes, somebody was speaking. So except if the reviewer
somebody wrote
and
test of significance. Is that a question? Okay. Or that's Mina? Dr. Mina,
yes.
Is it a question?
Oh, no, he he answered it in the course of his presentation, but I think I will also check him out privately again. But he answered the question. I was trying to ask him, yes, that is supposed to be test of significance, but he just answered after.
Okay.
All right.
All right.
Thank you.
All right.
So
Thank
much.
you. Thank you too.
All right. Isa Idris, I see you're muted. Do you want to ask the question? Isa Idris? Okay, all right. Okay, so without wasting any more time, I think I will just say a really big thank you to our reviewer, to Professor Shoyinka, who had to leave, to Mr. Emeka, doing what he does best, and to everybody for attending. We have another meeting next month. I'll be sharing the details on the various groups with the same Professor Shoyinka and of course our in-house biostatistician. And there's a Dr. Gidado, but he's not here now. He's also a senior registrar in psychiatry, so he's taking the next article. So thank you so much, everybody, and then we'll see you again next month. We'll upload the recording on all the AuthorAid Research Hub platforms. So if you'd like to see, you have access to it, hopefully within the next 24 hours. Have a lovely weekend, everybody. Sorry, Dr. Bakari, did you want to say something? I noticed you're muted.
Thank you. I just wanted to thank you for inviting us for the meeting. It's a lot of experience for the younger ones.
Go ahead, please. It was echoing. Go ahead.
I say it's a lot of experience acquisition for the younger ones, and it's a good thing. I think we should continue in the same direction. It's very good.
Thank you.
This is my first time of attending.
Oh, so we're going to be calling you more.
It looks very good.
Thank you. Thank you. I will be inviting you. Next month is also a psychiatry paper, and Professor Shoyinka will be here too. So I'll send you a reminder.
Okay. All right. Take care.
Thank you. Thank you, everybody. Have a really wonderful weekend, everybody. Thank you.